a 0.
Recording started.
Down there, and it's going to be undefined. So we got to factor. How can we factor this trinomial? To do so, find two numbers that multiply to 10 but add to 3. Two numbers that multiply to 10 are 5 and 2. Now we can make it -5 and +2, or +5 and -2. Now we want to make it +5 and -2 because those two numbers add up to +3. So therefore x squared plus 3x minus 10 can be factored as x plus 5 times x minus 2. And we need to rewrite the limit expression. So notice that we can cancel the factor x minus 2. And so we're left with the limit as x approaches 2 of x plus 5. So now we can use direct substitution. We're not going to get a 0 in the denominator anymore. So it's going to be 2 plus 5, which is 7. So that's the limit. Here's another problem that you could try. What is the limit as x approaches 3 of x squared minus 9 divided by x minus 3? So what do you think? What is the answer to this problem? Well, we need to factor x squared minus 9, and we can use the difference of perfect squares formula. So for example, if you have a squared minus b squared, it's going to be a plus b times a minus b. So for example, let's say if we have x squared minus 25. The square root of x squared is x, the square root of 25 is 5, and one is going to be positive and the other is going to be negative. That's how you can factor it. So for the example that we have, the square root of x squared, as we said before, is x, and the square root of 9 is 3, and so it's going to be x plus 3 and x minus 3. So we can cancel with the 3 on the bottom. And now we're left over with the limit as x approaches 3 of x plus 3. And now let's use direct substitution. So it's going to be 3 plus 3, which is equal to 6. And so that's how we can evaluate this particular limit. What is the limit as x approaches 2 of x cubed minus 8 divided by x minus 2? What would you do in that case? So what we need to do is factor the difference of perfect cubes. And the formula that we need to use is this one. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. So in this case, a cubed is x cubed, b to the third is 8. So a is the cube root of x cubed, which is x, and the b is the cube root of 8, which is 2. A squared, that's x times x, which is x squared. ab, that's x times 2, or 2x, and b squared is 2 squared, which is 4. So therefore we have the expression, the limit as x approaches 2, x minus 2 times x squared plus 2x plus 4 divided by x minus 2. Alright, let's get rid of this stuff on the bottom. And now we can cancel the x minus 2 factor. So we have the limit as x approaches 2 of this remaining expression. And now let's use direct substitution. So this is equal to 2 squared plus 2 times 2 plus 4. 2 squared is 4, 2 times 2 is 4, and 4 plus 4 plus 4 3 times is the same as 4 times 3, which is 12. And so that's the limit as x approaches 2 of this expression. So you need to be familiar with the different factoring techniques that you've learned in a typical algebra course. Now, let's try it this one. What is the limit as x approaches 4 of 4 minus x divided by x squared minus 16. So take a minute and pause the video. See if you can get this one right. So what do you think we need to do here? So looking at x squared minus 16, we can see that we have a difference of perfect squares situation. So to factor it, it's going to be x plus 4 times x minus 4. But 4 minus x and x minus 4, they don't really cancel at the present moment. However, what we can do is factor out a negative 1. If we take out a negative 1 in the front and then reverse the order of 4 minus x, notice that if you take a negative from negative x, you're going to get positive x. If you take a negative from positive 4, it changes to negative 4. So by factoring out a negative 1, we now can cancel x minus 4. And so what we have left over is the limit as x approaches 4 of negative 1 divided by x plus 4. And so this is going to be negative 1 over 4 plus 4, and 4 plus 4 is 8. So the answer is negative 1 divided by 8. Now what is the limit as x approaches 4 of the expression x squared minus x minus 12 divided by x squared plus x minus 20? So we just need to factor completely. Let's go ahead and factor this expression. So what two numbers multiply to negative 12 but add to the middle coefficient negative 1? So we know 4 times 3 is 12. But we need to make the 4 negative because negative 4 plus positive 3 is negative 1. So this is going to be x minus 4 times x plus 3. Now what two numbers multiply to negative 20 but add to 1? Well, we know 5 times 4 is 20. But we need to make it positive 5 and negative 4 because that's going to add up to 1. So it's x plus 5 times x minus 4. So we can cancel x minus 4. And so we're left with the limit as x approaches 4 of x plus 3 divided by x plus 5. So if we plug in 4, it's going to be 4 plus 3 over 4 plus 5. Now 4 plus 3, we know it's 7. 4 plus 5 is 9. And so that's the answer, 7 divided by 9. What is the limit as x approaches negative 1 of the expression 2x squared minus x minus 3 over x plus 1? So what can we do here? What would you do? So first, we can't plug in negative 1 because on the bottom it's going to give us 0, and so that's undefined. But we need to factor this trinomial. But notice that the leading coefficient is not 1, so the way in which we factor it is going to be different. So first, let's multiply 2 times negative 3. 2 times negative 3 is negative 6. What two numbers multiply to negative 6 but add to the middle coefficient of negative 1? This is going to be negative 3 and 2. So to factor it, we're going to replace the middle term, negative x, with positive 2x minus 3x. Next, let's factor by grouping. In the first two terms, take out the GCF, which is 2x, and so you'd be left with x plus 1. In the last two terms, take out the greatest common factor, which is negative 3, and so you're going to get x plus 1. Next, factor out x plus 1, so we're going to write it once. If we take out x plus 1 from the first term, we'll be left with 2x. If we take it out from the second term, we're going to have negative 3 left over. So therefore, we could say this is equal to the limit as x approaches negative 1, x plus 1 times 2x minus 3 divided by x plus 1. So now we can cancel x plus 1. And so we're left with the limit as x approaches negative 1 of 2x minus 3. So now let's use direct substitution. So this is going to be 2 times negative 1 minus 3, which is negative 2 minus 3, and that's equal to negative 5. So that's the final answer. For we could say this is terms, take out the GCF, which is 2x. And so you'd be left with x plus 1. In the last two terms, take out the greatest common factor, which is negative 3. And so you're going to get x plus 1. Next, factor out x plus 1, so we're going to write it once. If we take out x plus 1 from the first term, we'll be left with 2x. If we take it out from the second term, we're going to have negative 3 left over. So therefore, we could say this is equal to the limit as x approaches negative 1, x plus 1 times 2x minus 3 divided by x plus 1. So now we can cancel x plus 1. And so we're left with the limit as x approaches negative 1 of 2x minus 3. So now let's use direct substitution. So this is going to be 2 times negative 1. In this video, we're going to focus on dividing polynomial functions using synthetic division. So let's start with this example. Let's say we have x cubed minus 2x squared minus 5x plus 6. And let's divide it by x minus 3 using synthetic division. How can we do this? Well, first, let's draw this. On the inside, you want to put the coefficients of this function. So it's 1x cubed minus 2x squared minus 5x plus 6. Now, you need to put a number here. What number do you think goes in that region? If you take this factor, x minus 3, and if you set it equal to 0 and solve for x, you'll see that x is equal to 3. That's one of the zeros of the function. At least sometimes it's a 0. But basically, if you see minus 3, reverse it. So in this case, we're going to use positive 3. So let's bring down a 1. 3 times 1 is 3. Negative 2 plus 3 is 1. And then multiply. 3 times 1 is 3. And then add. So you're going to multiply, add, and keep doing that. Negative 5 plus 3 is negative 2, and then multiply. 3 times negative 2 is negative 6. And the remainder is 0. If the remainder is 0, that means that this is a factor of this function, which means 3 is one of the zeros. If you don't get a 0 here, then this is not a factor. It's not factorable by x minus 3. But if you do get a 0, this function is factorable by x minus 3. So something to keep in mind. So what does this all mean? Now, x cubed divided by x is x squared. So the first number is the coefficient for x squared. So we have 1x squared and then plus 1x with a constant of negative 2. And so this is the answer. X cubed minus 2x squared minus 5x plus 6 divided by x minus 3 is equal to x squared plus x minus 2. Now let's try another example. Let's take x cubed plus 5x squared plus 7x plus 2. And let's divide it by x plus 2. So for the sake of practice, go ahead and try it. Feel free to pause the video. So if you set x plus 2 equal to 0 and solve for x, you'll get negative 2. So let's put that number out in the front. And the coefficients for this polynomial expression is going to be 1, 5, 7, and 2. So let's bring down the 1. And let's multiply. Negative 2 times 1 is negative 2. And then add. 5 plus negative 2 is 3. And then multiply. Negative 2 times 3 is negative 6. And 7 plus negative 6 is 1. And then negative 2 times 1 is negative 2. And 2 and negative 2 cancel. So once again, we have a remainder of 0, which means this expression is factorable by x plus 2. So the answer that we're looking for, it's 1x squared plus 3x plus 1. So this is the solution after you divide by these two expressions. Now let's move on to our third example. 3x squared plus 7x minus 20 divided by x plus 5. Go ahead and divide these two using synthetic division. So first, let's set x plus 5 equal to 0. So if we subtract both sides by 5, we're going to use negative 5. And the coefficients are 3, 7, and negative 20. So let's bring down the 3 first. Negative 5 times 3, that's negative 15. And then 7 plus negative 15 is negative 8. And then negative 5 times negative 8, that's positive 40. And negative 20 plus 40, that's 20. So this time, the remainder is not 0, it's 20. So this expression is not factorable by x plus 5. Nevertheless, we can still divide it. So after we divide these two functions, or these two expressions, what do we get? 3x squared divided by x is 3x. So this is not going to be 3x squared, this is going to be 3x, and then minus 8. Now, if you have a remainder that's not 0, what do you do with it? It's going to be the remainder, 20, divided by what you tried to divide it by, which is x plus 5. So 3x squared plus 7x minus 20 divided by x plus 5 is equal to this expression. 3x minus 8 plus 20 divided by x plus 5. So that's what you need to do if you don't have a remainder of 0. You need to add r divided by whatever you try to divide it by. So this is the answer for the problem. Number 4. 7x cubed plus 6x minus 8 divided by x minus 4. Now this one is a little different than the last three problems. So go ahead and try this problem, but be careful. So once again, if we set x minus 4 equal to 0, if we add 4 to both sides, x will equal 4. So let's put a 4 on the outside. Now what are the coefficients that we need to write for this problem? Now if you put 7, 6, and negative 8, you won't get the answer right. When you write the polynomial function, you need to be aware of 0x squared. So you need to write this in descendant order. The 0 is very important. So it's going to be 7, 0, 6, negative 8. So if you forget this 0, your answer will be different than what it should be. So let's bring down the 7. 4 times 7 is 28. And 0 plus 28 is 28. Now 4 times 28. 4 times 20 is 80. 4 times 8 is 32. 80 plus 32, that's going to be 112. And 6 plus 112 is 118. Now 4 times 118. So 4 times 100 is 400. 4 times 10 is 40. And 4 times 8 is 32. So 40 and 32 is 72 plus 400. That's going to be 472. And negative 8 plus 472 is 464. And so that is the remainder. Now 7x cubed divided by x is 7x squared. So that's going to give us the first term. It's going to be 7x squared and then plus 28x plus a constant of 118 plus the remainder of 464 divided by what you tried to divide it by, x minus 4. So this is the final answer of the problem. Now let's work on one more example. 3x to the 4th minus 5x squared plus 6 divided by x minus 2. It's very similar to the last example, so for the sake of practice, pause the video and try this problem. So let's set x minus 2 equal to 0. So adding 2 to both sides, x is 2. Now keep in mind, don't forget about the 0x cubed and also 0x. So there's two zeros that we have to deal with. in this synthetic division problem. So we have 3, 0, -5, 0, and 6. So let's bring down the 3. 2 times 3 is 6. 0 plus 6 is 6. And then 2 times 6 is 12. -5 plus 12 is 7. 2 times 7 is 14. 0 plus 14 is 14. And then 2 times 14 is 28. 6 plus 28 is 34. Now, 3x to the 4th divided by x is going to be 3x cubed. So let's bring this down. This is going to be 3x cubed, and in descending order, the next one is going to be 6x squared plus 7x plus 14, and we have a remainder of 34. So it's going to be plus the remainder divided by what you tried to divide it by, x minus 2. And so this is the final answer. So 3x to the 4th minus 5x squared plus 6 divided by x minus 2 is equal to everything that you see in the blue box. And that's it for this video. So now you know how to divide using synthetic division. Hopefully you found it to be helpful. So thanks for watching.
No fucking way. Holy shit.
In this video, we're going to focus on using the factor theorem to solve polynomial equations.
Yeah, thank you for fucking stealing my toast.
What is the limit as x approaches 4 of square root x minus 2 over x minus 4? So what should you do under these circumstances. We can't factor this expression. So how can we simplify? If we plug in 4, 4 minus 4 is 0, the function will be undefined. So we can't use direct substitution. We don't want a 0 in the bottom. Whenever you have a radical, what you need to do is multiply by the conjugate. The conjugate of root x minus 2 is the square root of x plus 2. And whatever you do to the top, you must also do to the bottom. So on top, we're going to FOIL. X times x, or rather, the square root of x times the square root of x is the square root of x squared, which simplifies to x. And then root x times 2, that's going to be positive 2 square root x. These two, that's going to produce negative 2 root x. And finally, negative 2 times negative 2 is negative 4. Now on the bottom, we're not going to FOIL. We're simply going to rewrite it exactly the way it is. Now, 2 root x plus negative 2 root x, these two cancel. And so we're left with the limit as x approaches 4 of x minus 4 divided by x minus 4 times the square root of x plus 2. So now these two expressions will cancel. And so we're left with the limit as x approaches 4 of 1 divided by the square root of x plus 2. So at this point, we can use direct substitution. So that's going to be equal to 1 divided by the square root of 4 plus 2, which the square root of 4 is 2. So we have 2 plus 2, which is 4. So the final answer is 1 over 4. Let's work on another problem. What is the limit as x approaches 0 of the square root x plus 2 minus square root 2 divided by x? So we can't plug in 0, otherwise we'll get a 0 in the bottom. So we got to get rid of that x somehow. So just like before, we're going to multiply the top and the bottom by the conjugate of the numerator. So on top, let's FOIL. So when we multiply these two, the square root of x plus 2 times the square root of x plus 2, that's simply going to equal x plus 2. And then if we multiply these two together, we're going to have square root 2 times square root x plus 2. I'm just going to leave it like that. And if we multiply these two, we can see that the middle terms will cancel. And finally, negative square root 2 times positive square root 2 is negative square root 4, which is negative 2. On the bottom, don't distribute. Simply rewrite it the way it is. Now these two terms will add up to 0. Positive 2 and negative 2 adds up to 0. So now what we have left over is this expression. At this point, we can cancel x. And once the x in the bottom is gone, we can now use direct substitution in the next step. So this is going to be, let's make some space. So this is equal to 1 over square root 0 plus 2 plus root 2. 0 plus 2 is 2. Now what is the square root of 2 plus the square root of 2? The coefficient in front of both of them is 1. 1 plus 1 is 2. So this is going to be 1 over 2 square root 2. Now, that's your final answer, but you could rationalize it if you want to. So let's multiply the top and the bottom by root 2. The square root of 2 times the square root of 2 is 2. And 2 times 2 is 4. So it's going to be root 2 divided by 4. That is the final answer. Now let's talk about the limit of rational functions. Let's say if we want to find the limit as x approaches 3 of 1 over x minus 1 over 3 divided by x minus 3. How can we do so? As we can see, we cannot use direct substitution. In the denominator, it's going to be 3 minus 3, which is 0, and it will be undefined. So what should we do under these circumstances? What we need to do is we need to multiply the top and the bottom by the common denominator of these two fractions, which is going to be 3x. Notice what happens if we do so. So let's distribute. 3x times 1 over x is equal to 3. 3x is the same as 3x over 1. These will cancel, and you'll be left with 3. So we're going to have a 3 on top, and then 3x times 1 over 3. The 3's cancel, leaving behind an x. Now we're not going to distribute the 3x on the bottom. We're just going to leave it in its factored form. And let's not forget to rewrite the limit expression. Now, notice that 3 minus x is similar to x minus 3, but it's not exactly the same. So what we need to do is we need to factor out the GCF, in this case negative 1. If we take out negative 1 and reverse 3 and x, negative x will become positive x, and positive 3 will change to negative 3. So now, at this point, we can cancel x minus 3. So we're left with the limit as x approaches 0, not 0, but 3, of negative 1 over 3x. And now we can use direct substitution. So it's negative 1 divided by 3 times 3, and so the final answer is negative 1 over 9. Let's try another similar example for the sake of practice. So this time we're going to have the limit as x approaches 0, 1 divided by x plus 2 minus 1 over 2 divided by x. So go ahead and try this problem. So notice that the common denominator between these two fractions is x plus 2 times 2. So let's multiply the top and the bottom by x plus 2 and 2. So now if we distribute, these two will cancel, leaving behind a 2. So we're going to have the limit as x approaches 0 with 2 on top. And when we multiply these two, this time the 2's will cancel, leaving behind x plus 2 with a negative sign in front of it. On the bottom, we're going to have an x, a 2, and an x plus 2. We're not going to distribute anything on the bottom. Now let's distribute the negative sign on top to these two terms. So now we have the limit as x approaches 0, and that's going to be 2 minus x minus 2 divided by 2x times x plus 2. So positive 2 and negative 2 will add up to 0. So we can get rid of those two. Now, in the next step, we can cancel something else. Notice that we can get rid of an x. Once we get rid of the x in the bottom, we can now substitute at this point. So we have negative 1 divided by 2 times x plus 2. So this is equal to negative 1 divided by 2 times 0 plus 2, which is 0 plus 2 is the same as 2, and 2 times 2 is 4. So the final answer is negative 1 divided by 4. 2 times 0 plus 2, which is 0 plus 2 is the same as 2, and 2 times 2 is 4. So the final answer is negative 1 divided by 4. how can we evaluate this limit? What is the limit as x approaches 9 for the function 1 over square root x minus 1 over 3 divided by x minus 9? Feel free to try this problem if you want to. Now, in this problem, we have radicals and we have fractions. What do you think is the first thing that we need to do in order to evaluate the limit? Well, you could try direct substitution. If you plug in 9, you're going to get 9 minus 9 on the bottom, and on the top 1 over the square root of 9 minus 1 over 3. The square root of 9 is 3.